In this video, I want to have a look at the cosine. So here we've got a non-right angle triangle and we've labelled all its sides and its vertices. So it's important to notice that the side opposite angle A is little a, side opposite angle C is little c, and the side opposite angle B is little b. So they're always opposite and they're named the same. So our cosine rule is written here, and it starts off looking a little bit like Pythagoras' theorem. So we've got c squared equals a squared plus b squared. That bit is Pythagoras' theorem. And then we've also got this minus 2ab cos c on the end. What's important is that this c here, so that's representing the length of one of the sides, that side has to be opposite the angle that we used down here. So let's have a look at what that looks like in an example. Alright, so our example is written here. We've got a triangle with an angle of 50 degrees down the bottom, a side of 7 metres, a side of 3 metres, and we're asked to find the length of this side up here, this d. So we're going to substitute all of this into our formula. So we've got our d metres, so that's going to be in our formula, that's going to be our c, that's the side that we're trying to find. And it's also opposite our angle 50, so our 50 degrees is what's going to go in here. Our a and our b are our 7 and our 3, so it doesn't matter which order they go in, as long as one of them's a, one of them's b. So let's fill it in. So we're going to have d squared is equal to 7 squared plus 3 squared minus 2 times 7 times 3 times cos of 50 degrees. So this whole huge thing, we're going to put all of that in our calculators, and we're going to come out to get something like 31.0029, and it's going to continue. But that's what d squared is. We want to know what d is, so we're going to have to take the square root of this number, and it's going to give us approximately 5.57 metres if we rounded it to 2 decimal places. Alright, so that's one example using the cosine rule to find the length of a missing side. Right, so this formula here, this is actually given to you on your formula sheet. And it's really handy when it's arranged like this to find the length of that missing side. But in some questions we'll be asked instead to find the size of an unknown angle. So we sort of want to rearrange this formula a little bit so that we have this big capital C as our subject of our equation instead. So let's go through and rearrange that. The first thing we're going to do is get rid of these a squared plus b squared. We're going to subtract those from both sides of that equation. So we're going to end up with c squared minus a squared plus b squared equals minus 2ab cos c. So we've got that. Now we're going to get rid of this whole coefficient. So we're going to divide both sides of that equation by that minus 2ab. Just this coefficient. The cos isn't a coefficient, it's just this bit. We're going to divide both sides by that minus 2ab. So we're going to have cos c over this side, and over here we're going to have c squared minus a squared, that should be minus b squared, not a plus, minus b squared, because we subtracted it from that side, so that should be negative, over minus 2ab. Now it's looking a bit messy with all our negatives there, so let's go through and divide everything by minus 1. So what we can rearrange that to is we can make our a and our b positive, and our c squared will become negative, and this term down here will become positive as well. So we're dividing every term in here by minus 1. So we're going to end up with a squared plus b squared minus c squared over 2ab equals cos c. And we'll leave it like that. We could rearrange it a little bit more just to get the c on its own, so we go cos inverse of this whole thing. But then it starts to become messier instead of nicer. So I'm just going to rewrite this up here, and then we're going to have a look at an example of how we can use that to find the size of an unknown angle. Alright, so our second example is this one here. So we've got all 3 sides of our triangle. This time we've got 9.4 metres, 8.6 and 10.1. And this time we're trying to find this angle in here, that theta. So our theta is going to be our c in our formula, which means that this lowercase c in the middle of our formula has to be the side that's opposite. It has to be our 8.6. So our 9.4 and our 10.1 can be our A and B, and it doesn't matter which order they go in. So if we plug those things in, we're going to have cos theta is equal to 9.4 squared plus 10.1 squared minus 8.6 squared, or 2 times 9.4 times 10.1. Now if we put that whole thing in our calculator, we're going to end up with about 0. Actually, I won't do that. Don't rub it out when it's wet. We're going to get equal to 0.613, and that number keeps going in your calculator. And you're not going to round that yet. You're going to leave that whole number there because we haven't got to our final answer yet. So then if we're trying to find theta, we're going to go cos inverse of that 0.613 and that whole thing. And then we can round our answer. We're going to round this one to the nearest minute, and it's going to give us 52 degrees and 11 minutes. Alright, so that's just a few examples of how we can use the cosine rule to find the lengths of missing sides and the size of missing angles.